these questions with multiple accelerations going on here. So we have A on a table and we have mu. We have A is 4m, B is 3m, C and D are m and 2m, 1 and 2. We could call them 1 and 2, but I think it's good maths to put the m's in just to begin anyway. So what direction are they going in? We have 6, 3, 1 and 2 pulling down 4, so A is going to go in this direction with an acceleration of A, which means B will be going down with an acceleration of A. 2 is going to come down with an acceleration of B, and it's also going to come down with an acceleration of A. And C is going to move up with the acceleration of B, and it's going to move down with an acceleration of A. So we have B minus A, we have A plus B for my accelerations, and that should help us form our equations here. A, we have mu or going back this way, we have or, we have 4mg, and we have string going in this direction here, and we're calling that T1, and we'll call the other one T2. So we can say or is equal to, just put my A in, or is equal to 4mg, so mu or is equal to a half of that, 2mg. So we have T1, well, it's moving in the direction of mu or, so we have 2mg. Oh, sorry, it's moving in the direction of T1. What am I talking about? It's T1 minus my mu or 2mg, the opposing force, the opposite direction, is equal to m, which is 4m times g. Sorry, times A. When we look at B, there's one string going up, there's 2 strings going down. And we have its weight 3m, so we have 3m g going down, and it's going down with acceleration of A. So for B we have 2t2 plus 3mg, 2t2 plus 3mg minus t1 is equal to 3ma. And for C, we have one string, which is T2. We have mg, C is just m, so mg. And we have my acceleration over here of B minus A, which we calculated already. So C is going up. So we're going to have T2 minus mg is equal to m times A, which is B minus A. And we have D, which is going down with an acceleration of A plus B. We've got 2mg, we've T2, and we have the direction of acceleration. So we're looking at 2mg minus T2 is equal to m, which is 2m, times A, which is A plus B. Now, if we can solve for A and B, I've got my 4 equations here. I'll just box them to make them stand out a little bit. 1, 2, 3, 4. So in the first equation, I can cancel T1. May as well start with that. So I'm bringing these first 2 together. So let me write the answer to that up above. I'm going to cancel my T1s and get 2T2 plus mg is equal to 4ma plus 3ma, 7ma. So I have an equation with T2. If I could get rid of that, I could write the last two I can combine. I can definitely do that, can't I? And get rid of these T2. So if I can combine them, I'm going to get 2mg minus mg, which is just mg. That's going to be equal to, well, we have mb here. I'll multiply it out. M times mb, and we have 2mb, so that's going to be 3mb. And we're going to have minus ma plus 2ma is just plus 1ma. So if I look to get rid of T2 between these two, that will help me. And I have T1 is equal to, up here I could say 2mg plus 4ma if I need to use that. So if I multiply this one, I'll do the bottom one. I'll multiply the bottom one out. 2mg minus T2 is equal to 2ma plus 2mb, and I want to get rid of plus T2, so I'm just going to multiply this by 2. 4mg minus 2 T2 is equal to 4ma plus 4mb. I'm bringing down this equation. 2T2 plus 3mg minus T1 is equal to 3ma. So now I have 7mg minus T1 is equal to 7ma plus 4mb. And we said we could write T1 in terms of something. T1 is equal to 4ma plus 2mg. So 7mg minus 4ma minus 2mg minus 4ma minus 2mg is equal to 7ma plus 4mb. So I am going to get 5mg is equal to, what's these two? 7ma plus 4ma, 11ma plus 4mb. We have another equation with just b and a. So I have mg is equal to 3mb plus ma. mg is equal to 3mb plus ma. You can see how you can call the m's ones at the beginning and then have your different values. Divide by m. So we're going to get 6g. Well, I'm not going to combine them yet. Multiply, I'll just write them out again, make them neat. 5g is equal to 11a plus 4b, and g is equal to 3b plus a. So multiplying the bottom one by minus 4, I'm going to get minus 4g is equal to minus 12b minus 4a. And if I write 5g is equal to 11a, no, written the wrong one. Let me just, I have my a's and b's the wrong way around. Just let me go back there. So I mixed up my a's and b's. Second one by 11. 11g is equal to 11a plus 33b. And I've got minus 5g, multiplying this one by minus 1 is equal to minus 11a minus 4b. Combining these, I'm going to get 6g is equal to 29b. So b is equal to 6g over 29 meters per second squared. A is equal to g minus 3b. So A is equal to 29g over 29 minus 3 of them. 3 times 6g over 29. So A is equal to 29 minus 18. And then 29 minus 18 is 11g over 29. That's A and B. What were we asked for? All the way back 10 minutes ago, we are asked for find the common acceleration and also find the common acceleration of C and D relative to B and the actual acceleration of D. So there's a bit more work involved. So just write my accelerations out again. We got A to be 11g over 29. We got B to be 6g over 29. Was it the other way around? So particle D is just A plus B. The other two we have. We have B, which is this part, the second part, and we have A. So A plus B is equal to 17 g over 29, which is the common acceleration, the actual acceleration of D.